Welcome to Leetcode's Blind Curated 75, where I'll be solving the top 75 Leetcode questions. This problem is called unique paths, and it's a classic dynamic programming problem. Here's the problem. We have a robot that's located at the top left corner of a 2D grid with m times n. M is going to be the number of rows, and n is going to be the number of columns. Now the robot can only move right or down at any point in time, and the robot is trying to reach the bottom right corner of the grid. How many possible unique paths are there? Now this problem gives you a good basis of how we use DP, because normally you might think, oh, we'll have to do this like recursively. We'll have to find some recursion and find the number of paths that get here, but we don't need to do that. We could store all that data in some DP array, and here it's going to be a 2D array, right? So knowing that this robot can only move right and only move down, we already can tell on the first row these will all be ones because there's only one unique path that they can get to. You can only move right, so there's never going to be a time where you can go up. So all of these will be one. Same with the first column. All of these will be one because you can only move down or right, so you can never move left into here. So all these will also be one. Now knowing that, since we have this base amount or base array that we could base our summation on, now we can just start with the first or the second column on the second row and say, well, how many unique paths were there from coming up since we're coming down, and how many paths are there from coming left because we can only go right? And here it's going to be 1, so this will be 2. Then we just build upon that. We say, all right, well here we know there's 2 paths, and what about up here? There's 1, so it's going to be 3. Move on, 4, 5, 6, whatever. And then we just move on to this row, and it's going to build up kind of like almost sub-problems, but we're doing this in a dynamic programming sort of way. So let's start by creating our DP array. We need a list of lists, right? And we'll just first create our list for, let's say, C in range of how many columns there are, which is going to be what? That will be n, right? And we need all these for how many rows. So we need these lists for, let's say, R in range of m. Now the first thing is we know everything in the first row is going to be ones. So let's just do that real quick. We'll say 4 columns in range of n. Just make everything on the first row column equal to 1. And same thing with the first column. So this is the first row. This is going to be the first column. We'll make all of these on the first column in every row equal to also 1. So this would be R, and make that in the first column. It's going to be 0 equal to 1. So now all we need to do is build it up, right? And we can just go in order. For R, it's R in range of, am I doing this right? R in range of M. Oh, okay, so I think I've mixed these. Okay, yeah, for R in range of M, but we're going to skip the first row, so 1 to range of M. And for C in range of 1 to N, skip the first column, we'll say, all right, RC just equals to the sum of whatever came up and whatever came to its left. So R minus 1C plus DP RC minus 1. So after that, we just return the very bottom right corner. So that'll just be DP minus 1 minus 1. Let's go and submit that. Oh, invalid syntax. Let's see, 4 and range of M. Oh, of course, I need like zeros in there. So this will be a DP array. It looks like it's working. Let's go and submit that. And there we go. So this is a very classic problem. I would definitely brush up on this because it will really help later when you get more like complex path solutions. All right, so thanks for watching my channel, and remember, do not trust me, I know nothing.